Alright, hello chemistry class. Today we're doing 2.4a, density basics. Our first objective is going to be understand the relationship between the extensive properties mass and volume and the intensity property density.
And then we're going to teach you to perform calculations involving mass, volume, and density in our second half of the video. Hey, Mr. Hunter, joke.
Alright.
What's heavier, a pound of rocks or a pound of feathers?
Well, it's a pound is a pound, so I'd imagine it's the same. A pound of rocks or a pound of feathers the same.
Okay, so here's our chemistry joke slash demonstration. What's heavier, or more massive, I should say, 55 grams of copper pellets, like we see on the left, or 55 grams of towering styrofoam cups?
Well, to be a smart person, I would say look at the scales at 55.7, 55.6. Well, obviously the copper is more massive, but what we're getting at is it's 55 grams of one and 55 grams of the other. So they weigh the same, but their difference is, of course, their volume.
Right. The copper takes up a lot less space to give you the same amount of mass than the styrofoam does. And that's exactly what we're getting at with this idea of density. And so that's what we're going to do first, is define density. And density definition would be it's the ratio of mass per unit of volume.
Mass per unit of volume. There we go.
And in a math equation, we can express this with a D for density equal to M over V, the ratio of mass to volume. So M is mass in grams.
Normally given in grams, it can be given in other things.
That's right. And volume would normally in this unit be in milliliters or cubic centimeters, which is, of course, every chemistry student would know is exactly the same as milliliters. And then which gives us a density unit of, since they don't divide out, grams over milliliters or grams over cubic centimeters. And of course we don't say over, we say grams per milliliter or grams per cubic centimeter.
So looking back at our two pictures up there, which one would have a higher density just based on visual inspection?
So we're taking the same number on the top, 55-ish grams on each one.
Wow. Let's try this again.
Look at us go.
Yeah.
But we'd be dividing by a much smaller number of milliliters in the copper than we would with the styrofoam. The styrofoam's occupying a lot bigger amount of space for the same 55 grams of mass. So I'm saying if we take 55 and we divide by a bigger number, we're going to get a smaller answer than if we take 55 divided by a smaller number. Therefore, copper has the higher density.
Exactly. So, for example, let's say copper had a volume unit of 1, and the copper cups and the cups had a volume unit of 10. You would obviously say the density of copper would be much higher than the cups.
55 compared to 5.5.
Yeah, it would be 10 times higher. All right, on to some example problems.
Okay, so here's a basic problem. We're asked to find the density if we have 27.3 milliliters of a liquid and the liquid's mass is 31.4 grams.
So on the top is the mass, 31.4 grams, and the bottom would be 27.3 milliliters.
Okay, so let me punch this in the calculator here. 31.4 divided by 27.3. All right, here's the answer. 1.150183115.
1.150 grams per milliliter. Now, Mr. Ferguson, is this the right answer so far?
It is not. This is the calculator answer, but the calculator doesn't know that we're dividing to measurements, and measurements have significant digits, so we've got to take a look at those measurements to decide what we can put in our answer.
So this one has 3, the bottom one has 3, so our answer should only...
So we have 3.
You have to leave the least numbers of sig fig, so it would equal 1.15 grams per milliliters.
Okay, so that's a basic one. Just for point of reference, water what the metric system was designed around water. What's its density, Mr. Hunter?
Roughly 1, but it's really 0.998 or something like that.
Right, it's actually 1 if it's like almost freezing or something. It's right around, water's about 1. So anything that is more dense than water would sink if you put it in water. Anything
Exactly.
that's less dense
So if we put this liquid in water, we would expect it to what?
To sink right to the
So
bottom.
yes, this would sink
In water.
wow, that's horrible handwriting, but you all got it at home. Sink in water, H2O. All right, on to the next problem.
Okay, chemistry students, we have a second example problem. Sadly, Mr. Hunter can't be with me to work this one. He had another gig. I don't know whether you know he has a second career as a hand model or not, but anyway, next time you look at wedding rings quarterly, if you see the man hands with the beautiful wedding rings, one of them could be Mr. Hunter. So let's work this problem. What is the mass of a piece of zinc with a volume of 24.03 milliliters? And it tells us that the density of zinc is 6.97 grams per cubic centimeter. So, some of you are probably thinking, oh, well, I need that little triangle thing. Forget that. We don't like the triangle. We want you to use algebra to rearrange the equation if you need to. So our basic density equation is density is mass divided by volume. But if you read this question is asking us to find mass. So we need to solve the equation for mass, which I'm going to do by multiplying both sides of the equation by the volume, which will cancel it out here. And I'll flip it around and I'm going to have the rewritten equation as mass is volume multiplied by density. Substituting in, volume is 24.03 milliliters. The density of zinc is given, that's a given value, at 6.97 grams per centimeter cubed. And then when we crunch the numbers in the calculator is going to tell you that the density, or excuse me, that the mass should be 167.4891 milliliters cubic centimeters. The units don't cancel out. How do I know what unit to put on? Well, you need to remember that a cubic centimeter is the same thing as a milliliter, so that unit still divides out. So the only thing left is grams, so we're going to put grams on our answer. Okay, significant figure time. We see 4 significant figures in the volume measurement. And I know you might be thinking that there's 3 in this, but this is a given value, also known as a constant. And when we are given a value or a constant, it's been measured by so many different scientists over such a long period of time, that's considered to be a perfect number, which would mean it has infinite significant figures, which would mean it doesn't figure into our significant figures rounding in our answer. So the only measured value in the math equation is the 24.03 with 4 significant figures. So that's going to be 167.5 grams as the final answer. Alright, time for another example, Jersey Shore Chem students. Mr. Hunter couldn't be with me for this one either. He finished his first gig, and his second after-school gig is CIA agent. They needed him for a mission, so he's not going to be here, but I think I can help you work this one. So let's take a look at the problem. Find the volume of an aluminum chunk with a mass of 10.0 grams. The density of aluminum is given at 2.7 grams per milliliter. So first of all, I'm looking, 10.0 grams is measured. 2.7 grams per milliliter is a given. That's a constant, so that is not going to figure into my sig fig calculations. I'm only going to look at the measured value when I go to round, so I know I'm going to need 3 significant figures in the final answer that I give. So again, we go back to our main density relationship. Density of a substance is its mass divided by its volume. And in this case, we want to solve the equation for volume. So volume is in the denominator on the right. Let's first of all multiply both sides of the equation by volume, which will divide it out there. Now we have V times D, volume times density equals mass. Let's divide both sides of the equation by D, which will cancel out D on the left, and our relationship we want here is volume is mass divided by density. Okay, so we'll come over here, we're going to substitute in. Volume is 10.0 grams of mass divided by the density, the given value of 2.7 grams per milliliter of density. Let's take a look at our units. The units are grams divided by grams per milliliter. The grams divides out. So mathematically what we're left with in the units is 1 over milliliters, which is the same as milliliters. So we will end up with the volume unit in the answer. Taking the calculator and dividing 10.0 by 2.7, we get a volume of 3.7037 milliliters, or cubic centimeters if you prefer. But we aren't done. We have to think about how many digits we're actually allowed to report in this answer. So let's go back to our measured value. Remember, we said 10.0 grams has 3 significant figures, so we're going to round the volume to 3.70. Yes, I'm going to keep the 0. I'm going to intentionally write it because that is a significant digit in this answer. The unit stays milliliters, and we are done.
Alright, final example of the day. It's a little more tricky.
Put your big boy pants on for this one.
Put your math hat on if
Put
you
your
remember.
math
If you remember that from last year. Ethanol is a liquid. So we have a sample of ethanol that has a mass of 3.81 grams and a volume of 4.82889 milliliters. We then take this random solid and we find it has a mass of 4.35 grams and a volume of 5.8 cubic centimeters. And it is placed in the ethanol, or into the ethanol. We want to know if the solid will float or sink.
So, first of all, there's a lot of information thrown at you in this problem, but what you should be realizing is we have 2 separate materials.
That's step 1, is reading and figuring out what they want.
Ethanol, and we have this random
Sample,
solid.
or solid.
And we need to do 2 separate density calculations and then compare them at the end. Ethanol being a liquid, the solid will float in the ethanol if the solid's density is lower than that of ethanol. It's going to sink in the ethanol if its density is higher.
Exactly.
So the first thing we have to do before we can answer the question is find the density of each one. So we're going to go back to the ethanol and we're going to find its density using our mass divided by volume.
So it's going to be 3.81 grams.
So it's
divided by 4.82889 milliliters.
That must be a really good volume instrument used to measure that.
It's a very good volume instrument.
It goes to the gazillionth place.
And we divide those, so 4.82889, and we find out it has a density of 0.789.
And we can round it there because the top measurement, the number of grams, only has 3 sig figs in it, so we can only put 3 in our answer. And of course we're not done until we put a unit on it. The unit's going to be grams per milliliter.
Exactly.
Okay.
That makes it density. It's mass divided by volume.
So now we're going to do the solid. I'm going to change to blue for that one. So it's the same thing.
Density
is mass divided by volume.
Solid is 4.35 grams.
4.35 grams. It's
divided by
5.8 cubic centimeters.
I hit the calculator. It tells me the answer is 0.75. And that's it.
And that's it. We don't have to add any zeros because this measurement only has 2 sig figs.
Exactly.
0.75 grams per cubic centimeter.
All right.
Uh-oh.
So
this one's grams per cubic centimeter, and this one's grams per milliliter.
But we all know that 1 milliliter equals 1 cubic centimeter. So if you don't remember that from before,
so I could just change this unit to grams per milliliter.
yeah, no conversion necessary.
It's the same thing. Okay.
Right, so now thinking 0.789 is greater than, equal to, or less than 0.75.
0.75 is smaller than 0.789.
So in the world of density, the 0.75 one is going to do what?
Well, it's less dense, so it's going to float. So my answer is the solid will float in ethanol.
Exactly. Right.
Okay, so
this is where we're going to leave off for now. We're going to have another tutorial on more difficult density questions where we start introducing conversions and more difficult word problems. But for tonight, enjoy the easy density, and we'll see you tomorrow.